Alright, so this is our lab 4 for depth of field. So basically this lab was to implement bokeh depth of field effects. So you can see the final effect here with adjustable aperture. So you can kind of see that effect going. So basically how this works is when our aperture is 0 we simulate a pinhole camera, just to note. So how this works is what we do is we want to basically take our default image and we would need to calculate a circle of confusion for it. So basically what this is let's actually find the formula here. I should have prepped this earlier, but we can take this formula here, which basically tells us the blurriness for a pixel depending on its distance from the camera as well as some other camera parameters. And this basically tells us how much to blur by for every pixel, every fragment. So once we have that, we can do a horizontal blur. So this is a depth-aware horizontal blur. So you can see like this circle here at the front, it doesn't have any blur applied because it's within our focal range, whereas more distant objects get blurred more heavily. So then our next step is we want to do two diagonal blurs. So we take this image and we do two diagonal blurs. We do one going, you know, down to the left and one going down to the right. You think of it that way. So basically we have two images that look like this. So then what we need to do is we want to take the minimum or the and of both of these. Like if we think of this as a binary and, basically this is what we're trying to achieve. We've blurred it across, we've blurred it at the diagonals, and then we want to and it to get this, and we can do that using the min function. So basically that emulates the Boolean logic, and that gives us the final result of the nice hexagons. And yeah, that's basically depth-aware blur and bokeh and all that good stuff. Alright, cheers.